What I'd like to do in this video is to talk about the development of something called analytical skills. When you study mathematics, you might assume that all you really need is to learn basically a bunch of methods and how and when to use them. Let me write that down here. So how and when to use them. And this model of learning mathematics is probably important to a point, but if you're going to go into university study and you really want to get inside maths and do something more and get a lot more out of it, you have to develop something in your own ability which is we call analytical skills. Another term for it sometimes is, let's write it to get a different color, problem solving skills. So in this very short video, what I'd like to do is just introduce you to a 4-step method that you can initially start using whenever you get stuck. And then as the maths gets more complicated, you start seeing what you're learning is problem solving development around and using maths. And it's incredibly valuable because you can transfer it away from maths to any technical or pretty much any science, technology or engineering related subject, from computing to mechanical engineering and so on. So let's begin at the very first step. What is step 1 of this problem solving or analytical process? The very first step is quite simple. You're given a problem, right? And I'll write one which is unlikely that you're going to be able to solve. You're given that and you're asked to solve that. The very first thing you need to do, and it's a standard for all problem solving, is you need to, let's get the language right, identify the type of problem you have. Now, on one level you think, that's obvious, it's maths, so it's a maths problem. What else is there to do? Well, there's a little bit more than just saying it's a maths problem. That clearly is a maths problem. But what do we mean by type of problem? Well, when you look, let's get another marker. When you look at this over here, there are certain things and features of the problem presented to you, right? So here's a crucial element. There are features presented that give you an idea of what type of problem you are actually dealing with. Now, in this one here, that you won't have tackled unless you've done integration or calculus, the critical elements that you would notice are this funny shape here and this shape here, some numbers here and something here. And what you would spot is that the type of problem you have is something called an integration problem. So what I'm trying to get at is that that's for a mathematical problem. If you have a different type of problem, you still need to pin down looking at what's presented to you. So that's the crucial step when you do this very first step. You look at what's being presented and you draw from what's being presented an idea of the type of problem you're dealing with. Now, once you've got in your head the type of problem it is, if it's maths, it could be integration. If it's an engineering problem, it could be a mechanical issue. It's a whole range of different situations that you might do. But we're focusing on maths for the moment in this particular case. That's your very first step. You've got to identify. And the rationale, the reasoning, right? Very crucial concept here. You can't just look at it and say, oh, I think it's this problem. You've got to have some reasoning behind it. There are certain clues in the way the problem is presented to you and what's in the problem, which you formulate your idea of the type of problem you have. So it's quite a powerful skill. It's particularly important in computing engineering, for example. So after you've got some idea of the type of problem you're dealing with, you then move into a second step. So you enter the second step. You've identified the problem. The next trick is you're in a situation where, oh, I know what type of problem I'm dealing with. The question is, how am I going to go about solving it? Going to solve it or fix it, etc. So the question in step 2 is really, what tools, techniques, methods do I need to solve, and why should I use one particular technique or a tool rather than another? So it's not just simply in step 2, you know what type of problem you've got and you say, that tool will solve that and I'll use that. Really, to do step 2 and really get to grips with this, you have to have a reason of why you've selected these particular techniques and tools. In reality, the more complex the problem, you could select alternative tools and techniques and methods to solve it. And so, by having a reason for it, by giving yourself a reason, again, this really important word that comes into it, having a reason, meaning you can justify why you've chosen those tools and techniques, will link you back to the original problem. And they strengthen what are called your analytical skills. So, first step, you've identified. Step number 2, you've selected. So the crucial element, the crucial term here is selection. So step number 1 is identification. Step number 2 is selection of your tool, your technique, your method, whether it's engineering, mathematics, science, etc., etc. So you've now selected your tools. You've selected the methods and approaches you're going to take to solve this problem. Step 3 is quite simple. In step 3, you implement, or let's just use alternative words, you apply the tools, the techniques, or methods that you've selected. So this step is all about the actual application of it. Right, so you may have correctly identified a problem in step 1. Let's just put a little thing here. You may have correctly identified, which led you to step 2, which helped you select a bunch of methods. You may or may not have correctly selected a bunch of techniques. You're then in a situation, step 3, where you're applying those techniques. At every stage so far, you may have made a mistake. You may have, in step number 1, incorrectly identified the problem, which led you to correctly select methods for the type of problem you think it is, but it's actually not that problem. So it's a lot more complicated than you just black and white, that you just got it wrong when you identified it, because you may go on to correctly apply these selected techniques, even though you've incorrectly identified the problem. Now, these are all stages and steps of the analytical or the problem-solving method. And the final step is the one that most people just fixate on. So, step number 4 is the last step. You've identified. You've then selected your methods and approaches. You've then applied them and implemented them. And finally, in step number 4, this last step, you've basically produced an answer. Or in different problems, you may have solved the problem. And so on. Step 4 is the one that most people typically think is the only important one. What they think is, there's a method. If you remember the very first slide, here's a method, which is typically how it looks. Here's a method, you apply it. So you don't worry about the identification. You simply grab a method, apply it, and output the result. You are judged on whether your answer is correct and whether you've applied it correctly. The first 2 steps tend to be assumed and dismissed in a lower level in mathematics. Just the application of a method and the answer. Now, mathematics, which takes you to the lower levels, always has steps 3 and 4. You're always applying a method and you're always outputting a result. But when you come to higher mathematics, you need to introduce the whole process, because it's these 4 steps as a whole that actually make you a higher level mathematician or a higher level problem solver. So the consequence for you is that it's not just down to the answer you produce. It's not just down to the maths you write down. It's also about showing along the way some reasoning, some process of the selection of your method, which always links back to your ability to identify the problem you've got. So the identification of the problem is the absolute key. Seeing, spotting, recognizing the problem, which then, if it's done correctly and identified correctly, leads you through the 4 steps. And as long as you select the right method, you may, for example, recognize the problem, but actually be a little bit fuzzy about which right method to approach that particular problem. So step number 2 you may struggle with. But let's say that you do select the correct method, you do then carry it out correctly, and then the answer at the end is all correct. You almost get what you could call a perfect answer. Now in mathematics, in theory, it's possible to get this thing completely nailed down, identifying the problem correctly, selecting, applying, and then producing a result. But that's not the be-all and end-all. If you don't get this every step right, and you make mistakes along the way, as long as you explain your thoughts or reasons of a step, you are still developing your analytical skills, and actually you are doing something incredibly worthwhile. So don't get fixated on just producing the right answer. Get fixated on looking at the whole process from steps 1 through till 4. And when you apply that to your exams, your coursework, real life, real world situations, different situations, you will find it's developed a bunch of skills, what you would call cognitive skills. Let's write that down. That can transfer outside of mathematics.